Okay, let's now try to find the surface area of a rectangular pyramid. Alright, so it helps to draw the net, and the net is the 2D representation of all the faces and the bases that make up this pyramid. So we'll start off with the easy one down here. Alright, 18 by 10. That's an 18 by 10 rectangle. So the base has an area of 180 square, is it inches? Or sorry, square meters. Okay, now for the triangle. So you got two triangles that have a base of 10, here and here. Okay, so the base is 10, and there's two of them, so we need to find the height. Now, this height of this triangle is not the height of the pyramid. This right here would be the height of the pyramid. We need to find this height, L, the slant height. So, what we're going to do is make a right triangle. Since this height goes right down to the middle of that rectangle, and it splits 18 in half, that's going to be 9. And we need to also know the height, so it's given to be 12. So if you do the Pythagorean theorem, 9 squared plus 12 squared is 225, take the square root, you get that the slant height is 15. So that tells us that this triangle has an area of 75 square meters by doing base times height divided by 2. And then when you double it, you get 150 square meters. So now we just have to find the area of the other two triangles that make up the lateral area of the pyramid. So like this triangle and this triangle back here. Okay, so I just rearranged this image a little bit. So right now we currently have the area of the base is 180. The area of the two triangles on the left and right that make up the lateral area is 150 added together. So we have to find the area of this red triangle, and there's another one back here, so we're going to double the area. Alright, so we need the slant height. We already know the base is 18 meters. Now the slant height, L, is the hypotenuse of this right triangle, where this side is 5, and this leg is 12, because it tells us the height is 12. And 5 is just half of 10, because this goes right down the middle of the square. So if we do the Pythagorean theorem, we get that the slant height would come out to be 13. So if we find the area of one of those triangles, we get 18 times 13 divided by 2, and we get 117. And there's two of those triangles, so we get 234 square meters. So to find the total surface area, we are just going to add up all of these numbers here. So we're going to do 180, the base, plus 150, which are these two triangles, plus 234, which are these two triangles that make up the lateral area, and all that adds up to 564 square meters. Okay, now cylinders are a little different. We don't really have to draw out the net. There is a formula you can use, but if the net helps, I encourage you to draw it out. The surface area of a cylinder is going to be 2 pi r squared, which comes from the two bases. So each base is a circle, so that's the pi r squared part. Then you double it because there's two circles. Then 2 pi r h comes from the lateral area. Alright, so if you were to think of this cylinder as like a can of soup, and if you stretched out this curved part, it would make like a soup can label that was a rectangle. Now, the height of that rectangle is the same height as the cylinder. So h is just the height of the cylinder. Okay. The base of that rectangle, if you imagine like wrapping that back around the can, it would form the circumference of this circle. And the formula for circumference is 2 pi r. So the base is 2 pi r, and the height is h, so base times height, 2 pi r h. So to find the surface area of a cylinder, you need to know the radius of the base and the height of the cylinder, and then the rest is just using the formula. Okay, for a cone, it's going to be pi r squared plus pi rl. Now, the pi r squared part is easy to explain. That's just the circle on the bottom. Now, the other part is also explainable. So this part of the cone has a surface area of pi rl, because if you imagine taking it and folding it out, alright, it would make a sector of a circle, where this distance right here is the distance from the tip of the cone to like the edge of the base. All right, that right there is going to be the slant height. Okay, and this part would wrap around the base of the cone. So that would be the circumference of the cone, 2 pi r. Now, if we took this and chopped it up into little triangles, an infinite amount of time, okay, so we chop them up into triangles, or little smaller sections, and then we place them like this, and we place them all together, it would look sort of like a parallelogram. And the smaller we chopped it up, the more it would look like a parallelogram. Now, it doesn't look exactly like a parallelogram because these are little rounded edges, but if you think of cutting them up infinite amount of times, it would look like a parallelogram. Now, the base of this parallelogram is going to be half of this arc, so it's going to be pi r. And the height of the parallelogram is L. It's the distance from like the bottom of one of these sectors to the edge. So that's where the pi r L comes from. It's the area of this rectangle right here. All right, in the next video, we'll show you how to apply these formulas.